Hello students, let's try to solve some more problems from matrices on the topic eigenvalues and eigenvectors. First question is, if lambda is a characteristic root of a matrix A, then the root of A inverse will be. If lambda is a root for for any matrix, then for A inverse the root will be 1 by lambda. So the correct answer is option number 1. Next question is, the eigenvalue of this given matrix is minimal polynomial for this matrix will be A minus lambda into B minus lambda into C minus lambda equals to 0. That's why we have the roots will be, or the eigenvalues will be A, B and C. The correct answer is option number 4. Next question is, if lambda is a characteristic root of a matrix A, then the root for the matrix A plus Ki. In case of our inverse, we simply inverse the eigenvalues. In case of this identity matrix, we simply have the root for this A plus Ki will be equals to K plus lambda, where lambda is the root of this matrix A. So the correct answer is option number 2. The next question is, the characteristic equation for this matrix will be, so it will be 3 minus lambda into 2 minus lambda minus 1 will be 0. When we solve this, we will have lambda square minus 5 lambda plus 7 equals to 0. That's why the correct answer will be option number A. Next question is, the distinct eigenvalues of the matrix of this form will be, the characteristic equation for this matrix will be minus lambda into lambda square minus 2 lambda will be 0. We will have, when we further solve this, we will have lambda equals to 0 and 2. So the correct answer will be option number D. Next question is, the minimal polynomial of the matrix, this one, as we can see that the given matrix is a block diagonal matrix. It is in the form of V00C. It is a diagonal, or you can say it is a block diagonal matrix. That's why for choosing the minimal polynomial, we will have, if this is A, then the characteristic equation for this A will be characteristic equation for B cross characteristic equation for C. For this B, this is our B, we will have the choice of the minimal polynomial will be lambda into lambda minus 6, or you can say x into x minus 6. And for this matrix, for this whole matrix, the choice of polynomial will be x minus 6 square into x. That's why we have the choice of polynomial is either x into x minus c and x into x minus 6 this whole square. As x minus 6 this whole square into x is not given in any option, that's why x into x minus 6 is a required minimal polynomial. So the correct answer is option number 4. Next question is, let alpha equals to e to the power 2 pi iota and the given matrix is this one. Then we have to find out the trace of the matrix. The trace of the matrix is nothing but the sum of eigenvalues. Since alpha is given as e to the power 2 pi iota upon phi, this means this is nothing but it shows that this alpha is the fifth root of unity. That means we have 1 plus alpha square plus alpha cube plus alpha to the power 4 will be equals to 0 and alpha to the power 5 will be equals to 1. Now by simple process, just calculate the characteristic root for this given equation, given matrix, it will give us lambda equals to 1 comma alpha square, alpha cube and alpha to the power 4. Now we have to calculate the trace of this matrix. So it will be 1 plus alpha square plus alpha cube plus alpha to the power 4. That is nothing but 0, because this alpha gives us the fifth root of unity. Okay, that means the trace of matrix, this given matrix M, is 0. Now the eigenvalues of M square will be 1 square alpha square, and like this it will give us 1 comma alpha square, alpha to the power 4, alpha and alpha cube. That's why the trace of this M square will be equals to 1 plus alpha square plus alpha to the power 4 plus alpha cube, which will again equals to 0, as alpha is the fifth root of unity. Now the eigenvalues for this I will be 1 plus 1 1 1 1 1. That is, the trace of I matrix will be 5, trace of M is 0, and the trace of M square is also 0. That's why the trace of I plus M square is 5. So the correct answer is 5. Next question is the minimal polynomial associative with this matrix. Just simply write the minimal polynomial for this, or the characteristic equation for this given matrix. We will have the minimal polynomial will be x cube minus x square minus 2x minus 3. So the correct answer will be option number 1. The next question is, which one of the following matrices is not diagonalizable? As we know that if a square matrix has all its eigenvalues equal, means it has equal eigenvalues and it is diagonalizable, then it has to be a diagonal matrix. Means what we are doing in this question is we are using the reverse approach. Means we are just checking out our option and then trying to crack down our answer. For this matrix fourth, the eigenvalues are 1 and 1. Means we have equal eigenvalues, but if this matrix is diagonalizable, then it must be a diagonal matrix. But it is not a diagonal matrix. That's why this is our correct option. This matrix is not diagonalizable. Our last question is, if the nullity of this matrix is 1. We are given with the nullity of any matrix, then we have to find out the value of this k. Simply, in such type of a equation, what we have to do is we have to reduce these matrices into the echelon form and then try to calculate the value of k. If we reduce this matrix, we will have this final matrix. If we have nullity 1, then rank will be 2. That means this row should be 0. That simply means 1 plus k should be 0. When we solve this, we have k equals to minus 1. Means if this matrix has 1 nullity, then the value of k equals to minus 1.